Thanks a lot, everyone, for joining. Again, good morning, good afternoon. My name is Hernan. I am from CrateDB and O-CELL, which is the company that has developed CrateDB, an open source distributed database system, which is designed to manage large amount of data and analyze them in real time. And today I am here with Charles from O-CELL. Hi, Charles, how are you?
I'm fine. Thank you for having me here today. Hi, everyone.
It's a pleasure to have you here today, Charles. For those in the audience that have not heard of O-CELL, they are a French company, and they have developed a solution to help businesses and local government lower their environmental footprint and save money on energy and water bills. And today, Charles will be telling us about his experience developing this solution, his motivations, the challenges that he faced, and it's going to be very interesting. If in case any questions come to mind, please enter them in the dedicated Q&A section in Zoom, and we will collect all the questions and answer them at the end of the webinar. And okay, maybe Charles, to get started, maybe you can tell us a bit about the solution, the background, the context, what the problem you were trying to solve.
Yes, sure. When we started the company back in 2017, we were looking at leveraging new technologies to solve existing problems. And we identified the emerging LoRa wireless technology as promising. And fortunately for us, we found a matching use case with a small town near Paris, which wanted to build a living lab to experiment with smart city concepts. The requirement they had was to have a multi-purpose platform that will be able to collect near real-time energy consumption prediction, as well as other environmental parameters, and provide easy-to-read dashboard for the city's representatives and in-depth data access for the technical staff. The system had to be able to detect abnormal behaviors and send alerts over different channels. So many use cases needed to be covered. As I said, energy consumption, water leak detection, air quality monitoring, cold chain monitoring, water level monitoring for rivers and flooding. And of course, adding new use cases were to be easy. So we designed a flexible solution built around dedicated services to ingest, process, and present the data. And hoping for success, of course, we had to consider reliability and scalability, both in terms of processing power and storage. So here, this schema shows you a very high-level architecture of the platform. So on the left side, you see that we have sensors that are collecting environmental data and sending this data over the LoRa wireless network. We also have third-party interfaces to collect data from other producing systems. And all this data is then sent to our ingestion framework, which will decode, process, normalize, store the data. The storage, of course, occurs in CrateDB. And on the right side, you have the consumers, which is the web UI, which is a responsive, mobile-friendly interface. Then we have the alerting system, which will basically monitor data flowing into the system and evaluate rules to trigger alerts when needed. These alerts are then sent over various channels like SMS, email, push notification, and so on. And then there is a REST API that is used by our mobile application and also by third-party customers to basically take the data and process it for the needs. So for the solution, we're using various sensors. So on this first slide here, you see sensors that are basically reading electrical pulses from pulse emitters. On the left one, you have an electrical meter that is sending pulses using a LED, and we have an optical reader that reads these flashes and send them to the sensor that you see on the top of the picture. On the middle image, again, here we are in a humid environment because we are monitoring water. So we have IP68 pulse sensors that are reading pulses sent by the pulse emitter you see on the bottom of the picture, that are clipped on the water meters and that are reading the needle that is basically showing the consumption level. And this reading is then transmitted as an impulse. And on the right side, we are in a potentially explosive atmosphere here. That's why we're using an ATEX certified sensor to read pulses that are sent directly by the gas meter that you see on the picture. So here again, on the left side, you have an ATEX sensor that is reading pulses from a fuel oil meter. And this is a boiler system, an industrial boiler system used to heat an holiday resort. On the middle picture, you have temperature sensor that is sitting in a cold room here. It's -20 degrees. And it's basically monitoring the temperature to ensure that the cold chain is maintained. And on the right side, air quality sensor that is monitoring temperature, humidity, CO2 level, and VOC level also.
Fantastic. And I think, yeah.
So,
sorry, go ahead.
No, sorry. So, so basically, when the UI was designed to go back to the solution and the platform, so we designed the UI together with our users to make sure that basically it matched their needs, and we ended up with a user-friendly and powerful tool that led our first partner city to purchase a license. From there on, we managed to sell to other municipalities, but we envisioned that the same need was present in other industries. So we decided to address campsites and holiday resorts since they were facing challenges with energy prices going up and the water resource becoming a more and more precious commodity. And of course, this would also help them lower their environmental footprint and promote their eco-friendliness. So today we have many well-known groups as customers, and our system helps them better understand how their facilities are consuming energy, water, to ensure that sensitive goods are stored at the right temperature, as well as make sure that customers are hosted in good condition. And of course, it helps them lower their bills by receiving alerts when abnormal situations are detected.
That sounds excellent. And you mentioned you will be able to detect things like water leaks, right? Could you tell us a bit about that?
Sure, that's correct. So with the water sensors that you saw on the previous slides, we are collecting water consumption information in near real time. And we have developed algorithm to detect leaks, whether they are big or small. The idea is pretty simple, just to look at the flow over the past 24 hours. And if the level has not reached zero at least one more time, then it means there is a constant flow in the pipes. In most cases, that means there is a leak. So the platform will detect that and send alerts. What we notice is that this works well for small leaks that are invisible and are billed every month without raising suspicion, since they are here all the time. And our experience shows that many customers have leaks that they're unaware of, and that the system helps them by saving money by stopping wasting the precious resources. In France, there are estimates that show that about 10% of the billed water is lost in leaks. So in the screenshots you see here, we are again in a holiday resort in France. And this is the water consumption of a foot bath that is installed near a swimming pool in a holiday resort. So every morning, a member of the staff has to come and open a faucet to renew the water, and it must come back later to manually close it. One can see that in a normal day, consumption is about 1.5 cubic meter. That is materialized here on the chart by the orange dashed line that you see on the bottom. But what we can see here is that on one day, the consumption spiked to 56 cubic meters, just because the staff member forgot to close the faucet. The system has just been installed, so the threshold was not configured yet, but it basically helped the customer see and noticed how much money he was wasting by such human mistakes. Later on, they set the threshold, and the alarm has been triggered quite a few times already, helping them save money and water.
Very good, very good. And I think you had another example concerning air conditioning units. Is that correct?
Yes, that's correct. So here we are. In the first CT that we equipped, we have sensors monitoring energy consumption in a public school. So on these charts, you see on the left side, it is the live electrical consumption throughout one day. And on the right charts, it is the electricity consumption on a month displayed at the daily level. What we can see, and on the bottom part, it is year 2019. On the top part, it is 1 year later in 2020. So what we can see on the bottom charts is that throughout the day, even at night, there is a constant energy consumption that we can see on the chart. And on the right, on the bottom right chart, you see that this basically translates into quite constant consumption throughout every weekday, whether the school is closed as on Sunday and Wednesdays, or whether it's a weekday. And so the city officials noticed that, and they basically linked this consumption to the newly air conditioning system that was just installed. So they requested their contractor to basically change the settings, and it resulted in the other charts where you see that basically the consumption has been drastically decreased. And by looking at the monthly consumption that you see on this slide, you can basically see that the consumption has been decreased by 25% on the last few months of 2020, which is basically equivalent to 3,000 euros saved on these months, which is a very good thing.
Yes, huge saving. That's very good. And I think that a central element here is that all these sensors generate a lot of data. So the database becomes kind of an integral, a key part of the solution. Could you tell us a bit about how you first learn about CrateDB and why you choose CrateDB to be the database for this system?
Yes. So having dealt with different database systems in the past, we knew that we had to make the right choice from day one. So during our technology assessment, we discovered CrateDB, and which seemed to solve many of the well-known nightmares what one can have with traditional DBs, which is data replication and sharding for resiliency, as well as scalability, both for storage and also power. So having a fault-tolerant cluster with automatic data replication and easy addition of new node to scale seemed like a very good promise. Having SQL interface supported out of the box by standard language and a flexible data model was also a plus. That's why we basically, after trial, we chose to go with CrateDB.
That's great to hear. And you have been using CrateDB since the early stages of the project, so and it's been a while now. So I wonder if you have noticed any improvements over time, with the evolution of the system over time.
Yes. So far our experience with Crate has been great. We're a small company, so we don't have lots of resources, and we need to use them wisely. So having a database like Crate, which needs very little to no maintenance, relieved us from having a full-time DBA and from spending hours solving replication issue or design session to see how we could scale data processing and storage power, as well as designing failover mechanisms. So when we that's what we felt so far, and we're CrateDB has delivered its promises.
Excellent. And I remember that a few months ago we worked on a major upgrade. You went through several versions up to version 5. any specific improvements in version 5 that you noticed that you found useful?
Yes, definitely. First one, which is the reason we'll go to that later, why we upgraded is for performances, and that's what we saw when we upgraded to 4.x then 5.x. That's for sure. Another great improvement was the native PostgreSQL SQL driver, which relieved us from using the CrateDB driver in the front end, and a better PostgreSQL compatibility, which also helped us a lot.
Perfect. And I think something the audience may be interested in is how you design the data schema in the database to store the data collected by the sensors. Could you tell us a bit about this, about your data schema?
Yes, sure. So one of the, as I explained earlier, one of the basic goal of the system was to be extensive and to be able to store a lot of data types, and also to be able to add new ones very easily. So the data is sent from the sensor as binary frames, and they're encoded according to sensors manufacturer specification. The IoT endpoint service receives this frame, store it in a dedicated table with metadata reflecting the LoRa signal quality, for example. The decoder service will then fetch those frames, process them using the corresponding algorithm, normalize the data, and store all the data as indicators. So these indicators are just time series, which can contain different data types sent from the same sensor and at the same time, which, for example, temperature, CO2, COV, and so on. The flexibility of Crate table model allows column with arrays and objects, which is great because it allows us to store all the indicators produced by the sensor at the same time into one single database row, which is great for storage and for query performances. The number and names of the various indicators can also vary over time, and we need to be able to add new ones without changing the data model. And thanks to CrateDB, this is possible. So the flexibility of the CrateDB model helps a lot for that.
Yes, we have lots of features, lots of flexibility around that, and of course, all this can be queried with a SQL language, which I think you mentioned you found useful.
Yes.
Was there any other feature that you found particularly interesting in CrateDB compared to other systems? Or?
Well, that's what I mentioned earlier. Crate as a high availability, sorry, and scalability that have been included in the product design since day zero. So it's great because the clustering and sharding mechanism, one can ensure that data is replicated to at least another machine, which means that a failure will not impact your whole system. No data loss, no downtime. So that's a huge benefit.
It's great to hear that you found it easy to use and scale. And you mentioned that you were able to manage it in production without the need to hire a dedicated person, without any need for a dedicated database administrator or anything like that, right?
Yes, as I said, usually how to deal with issues in databases are taken into account by design. So setting up the system, setting up a cluster, replicated cluster, failover, and so on is a no-brainer. It does not require new resources, and so that's at least so far up to our experience. We have no issues, and everything is easy and runs smoothly.
Perfect. And another question, maybe going back to your architecture slide, is what other tools make up your stack? What other tools have you integrated with CrateDB to build up your solution? If you could tell us a bit about that.
Sure. So we're using for the customer web portal, we're using Tomcat with a Java application that is using the Vaadin web application framework, which is great. So on this side, the Java integration with Crate was quite easy because Crate also provide a JDBC driver to interact directly with the database. So every standard Java framework can work on CrateDB, which is fine. We just had to make some custom enhancements to be able to leverage the blob storage of Crate, which runs on HTTP only. And then on the ingestion, data processing, alerting, and so on, we're using Go microservices that are using the HTTP endpoint that is provided by Crate. Fortunately enough, when we started the project, we found an open source Crate driver that was already leveraging this HTTP endpoint. We enhanced it a little bit to support more data types like objects and so on. And we've been running with that since day one, and we had no issues. So just when we migrated to Crate 4.x, one good thing is that thanks to the improved PostgreSQL compatibility built into the newer version, we were able to basically use the standard official PostgreSQL JDBC driver, and we might also move our microservices to the standard PostgreSQL Go driver. But so far we've had no need and no real urgency to do that, so we will postpone the change to later times.
Sure, the HTTP endpoint, of course, is fully supported as well as the Crate JDBC driver. Yep. So you can continue to use that. And if I am not making a mistake, you are running on Azure. Your infrastructure is running on Azure. Could you tell us a bit about how you made the choice to go for the cloud, and how has your experience been so far with that?
Yes. So one of the first requirements we had was to have data hosted in France, because we were running with the French government cities and so on. So we looked at the various cloud providers, and we found that Microsoft had data centers in France. Another good advantage of Microsoft is that the pricing model was a little bit easier to understand than the other providers. We also saw that Crate was supporting the Azure Cluster Discovery mechanism, which basically made us feel safe that if and when we needed to add more nodes to our cluster, it will also be a no-brainer. So that was another decision-making point. And so far, we've been pretty happy with this setting, and the system is running smoothly.
Perfect. Any chance you could give us a live demo of the system?
Yes, for sure. Let me share my screen. Okay, so here I'm actually connecting. So this is the map view of a holiday resort that is based on the French Riviera near Cannes. And so here on the map, you can see the various sensors that are on site. So for example, here I can click and go. So this is the swimming pool. So I can go there and basically look at that's the chart that we saw earlier. This is the foot bath where we've had many issues and a lot of water has been leaked there. If I go here, we're back on the chart that we saw earlier, where you see that here the orange dashed line means it's the threshold, and when the water consumption, the daily consumption, goes over the threshold, the alarm will be triggered. And we can see here that on several occasions the threshold's been crossed, and it means that the customer received an alert. And we can see here that we have, of course, very high consumption going on, where for a fixed period of time, which means that the faucet's not been closed, as I explained earlier. We can also go here, for example, on the this is the electricity consumption of the site. So you have here the various charts that are showing consumption for every month during the past 3 years. You see, we can go on daily consumption, where we basically, depending on the occupancy of the site and so on, we have different consumption levels. And here we can drill down and go to a measurement every 10 minutes, which basically allows you to make precise diagnosis on what your consumption is at any time of the day. We can also here go to the air quality monitoring sensor that you saw on the pictures earlier. So you see the thresholds here. Orange one means it's too hot. The dark blue one means it's getting cold. And the light blue one means it's getting very cold, near freezing, which might cause issues in the water pipes. Then you have the humidity here, and here the CO2 level. So you see spikes. Those spikes are basically, we are in a restaurant here, I forgot to mention, sorry. The spikes are when people are actually taking lunch, dinner, or breakfast. And here the air quality, the global air quality indicators. So we can go here and see the thresholds, how they are set. So you can see here, for example, that we have the low temperature at 16 degrees, and it will be triggered only if the temperature goes below the threshold for more than 1.5 hours. This basically prevents alarms from being triggered on and off if the temperature will be going up and down very near the threshold. And we can have a list here. We can look at all the history of the alerts that occurred on site. So you can see where it occurred, when, and by clicking here, you have more details about the different information about the alert. And there is a log mechanism here where staff members or technical members can enter information about what happened, how they solved the issues, and so on. That's it.
Perfect. Thank you very much, Charles. And now, before we move to the Q&A, I want to very quickly tell everyone about the new features that we had added in CrateDB 5.2. We had added 2 new aggregation functions, which are actually my favorite feature in this version, max by and min by, and they allow you to, in a very easy way, solve things like finding out what are the latest reported values for each device for a given parameter. This is something that, of course, you could do before with common table expressions, for instance, but with these new aggregation functions, queries become much more readable and also run a lot faster. We had also added the ability to add multiple columns in a single statement. We had made several improvements to enhance our compatibility with the standard tools by adding support for bit operators, backwards scrolling cursors, aggregations on interval fields. And we had also added some new scalar functions. We are able to combine multiple objects now with a concat call, and we can also parse URLs with these new functions that you see on the screen. And finally, but not least, we can also extract a specific parse from interval types. So, for instance, you can extract the hours, the minutes, or even the epoch, and that's very useful in certain contexts. If you want to learn more about this, you can take a look at the release notes. And it just goes to say that we're always improving the product. There are always new features coming. And as usual, if there is anything that we don't have at the moment that you would like to see in CrateDB, you can also raise a feature request directly in GitHub. And now let's take a look at the questions that came from the audience. So maybe we will start with this question here. So it's a question for Charles, and it says, did you experience any hardware or machine crashing or node crashing, and how did this impact the system?
Yes, we had this experience. I will say, of course. So on Azure, we had experience nodes rebooting or crashing. But the good news about that is thanks to CrateDB and the way we've designed the system, when the node crashed, basically we saw that the Crate cluster basically took over. We saw it replicating the missing shards to other nodes, and basically the user experience was not altered at all because the system continued working. Data was available. Data was able to be ingested, which is great. When the node recovered, basically the machine had rebooted, we saw that Crate basically resynchronized all the data from the other nodes, the data that has been added in between, and everything started running smoothly. I mean, not started, but continued running smoothly again. So it basically the promise that Crate made was absolutely good and great, and it worked, which is a very good relief.
I'm very happy to hear that.
Yeah.
We got a second question. This one is also for you, Charles, and it says, did you consider any other database system before settling on CrateDB? And what made you ultimately choose CrateDB?
Well, yes, as I said, we did technology assessment before choosing CrateDB. So we looked at the various, I would say, standard databases, which are, of course, so it's MySQL, PostgreSQL, Oracle, but none of these systems was as easy as Crate to basically build a fault-tolerant and resilient system with scalability and stability built from the ground up. As I said, we had already dealt with issues, replication issues, scalability issues with these other systems, and basically Crate was the easiest and greatest to go with.
Perfect. And there is another question here. They ask if you have noticed any performance advantage in using CrateDB compared to other databases.
Well, what we see is that the performances we have with Crate are very good. I think it might be because when you run a query, because of the clustering of the cluster, the query will be parallelized and run on many nodes at the same time, which basically yields very good results. Right now, we are running on a 3-node cluster, which is not that many nodes, and they are very low-end hardware with not much memory or CPU, and we have like tens of millions of rows in the database, and everything's running smoothly. I'm not sure we could have reached this level, this performance level, with other databases. So I've no regret going with Crate.
Fantastic. And there is another question here. This one came through the chat and now has just been posted as in the Q&A. They ask if you use Python in your solution.
For the production environment or production tools, we're not using Python. As I mentioned, we're using Java and Go. But for maintenance tools or so other utilities, we do use Python. And the great thing is that if you use the standard PostgreSQL Python driver, it works out of the box with Crate, which is fine.
Yes, indeed, we also have support for SQL Alchemy, including the newest version 2. So a lot of our customers use Python So there's an ecosystem that we pay a lot of attention to. And there is one more question. This person asks if they say, I would be interested in hearing more about replication and sharding features in CrateDB and how they contribute to high availability. Maybe that's one for me. Of course, sharding is about how data is distributed among the nodes in a CrateDB cluster. And CrateDB can handle all that automatically if you leave it to CrateDB. Otherwise, there are lots of settings that you can configure. Is really plenty of options there. And then replication. In this context, a replication means having more than one copy of the data. In case a node goes down for whatever reason, the data is still available on in the other nodes. And it's also something that helps for performance, because if the data is available on multiple nodes, queries concerning that data can be split into small tasks that each of the nodes can run in parallel, accessing the local copy of the data. So sharding and replication, the decisions that you make around that impact performance and also high availability. Yes, we actually have a webinar discussing this more in detail if you are interested, and you can find it on our YouTube channel, and we have plenty of tutorials as well in our community. By the way, I highly recommend taking a look at our community. It's community.crate.io. And there is one more question that just arrived. I think this one for you, Charles. So about the sensor that was looking at the pulses in the meter, the question is if you are capturing it as a sound or storing it as some kind of a string. I guess that's the question, I suppose. Can you
on the water meter, you mean? So if it's
so,
on the water meter, no, it's not the sound. It's basically on every meter there is a rotating needle, and the pulse emitter will basically detect every turn of the needle, which is translated into a volume, and this is then converted to pulses that are sent to the sensor.
Perfect. Thank you for explaining that, Charles. Now, maybe to close, I have a few remarks. We will be sharing with all the attendees a link to download a white paper on industrial IoT technologies. I think you may find that interesting. If you want to know more about CrateDB or O-CELL, please feel free to contact us. Also, you can visit our website, crate.io. And as I say, you can join our community, and you can find us in GitHub. If you like the project, please give us a star on GitHub. We are an open source project, so of course that helps. And in GitHub, you can find our roadmap, all issues, and and you can find all our source code. And if you are happy to, if you're interested in getting involved, you can also contribute. And one more thing, you can run CrateDB on your own servers on premises. Is licensed with the Apache 2 license, so you can run it for free. But if you don't want to have anything to worry about around infrastructure, backups, monitoring, or anything like that, you can use our fully managed solution, CrateDB Cloud. You can just by opening an account on our website, you get $200 credit that you can use to try out a cluster whatever way you wish. And we also got a free tier. So if you have a use case or maybe for development where you only need a very small instance of CrateDB, you can run that for free. And as long as it stays active, it remains free, so you can keep using it without paying any money, and you don't even need to enter credit card or payment details of any sort to get started. So you may find that interesting. And that's it. I hope you found the webinar interesting. Thank you very much again, Charles, for sharing your experience with us. And thank you to everyone that joined us today. Thank you again, Charles. Have a nice day.
Thanks for everyone for listening. Bye-bye.